Hi all, wanted to take you through a quick update on the power supply. Thought I'd mention quickly that I've now from OSHPark ordered the first couple of boards. We've ordered just the bulk capacitance board. That's being manufactured as we speak, and we should have it by next week, Monday-ish, this coming Friday or next week Monday. At which point we need to start buying components, etc. for that. On the bulk capacitance board, it's quick and easy. It's just the capacitors and diodes to make up the bridge rectifiers, as well as the toroidal transformers. So those will we'll buy those as soon as I get the boards back. Yeah, OSHPark also upgraded us for free to Super Swift service, which is quite nice. So now we're just waiting for the stuff to get here. OSHPark, if you're ever making PC boards, I highly recommend them. Very, very good quality boards, and they're pretty good. So I also wanted to quickly mention that something I didn't know, well, I sort of heard of, but I didn't quite know how well it worked, was getting sample parts from manufacturers. I went onto the TI website and had a look at the chips that I've designed into the power supply, and had a quick look, and it's actually quite easy. And what I wanted to do today is just show you how that worked, and then take you through the chips, show you a quick initial fit onto the diagram, onto a printout of the circuit board, show you how I do that. I like just doing a quick test fit on a standard print, just to make sure everything lines up and everything fits. And I also wanted to take you through a bit of a selection between op amps, and I'll tell you more about that later. So yeah, let's dive in and get going. So here we are at the TI homepage, and if you end up looking for a part, so let's have a look at an LM358. Once that comes up, you can have a look at the parts. I mean, this is obviously all straightforward, as you guys know. Search for a part, get into it. But the interesting thing I wanted to show you guys is when you have a look at sample and buy. So here we have obviously the entire description of the website, a couple of features. You can get all of the data sheet, all good. And then when you get over to sample and buy, you obviously have an option to have a look through the catalog. So these are all the different options they have, and you'll see for some of the packages and types and things, they have this request sample button, and that effectively works exactly the same as any other shopping cart. You click the button, you tell them how many you want, you fill in your address, and they ship it off to you, all free of charge. Now, obviously, depending on the chip, you might be limited to only 3 or 2 or 1 part each, and also, you don't necessarily use this as your standard form of shopping, because the guys would end up obviously not helping you out anymore. This specific project, the power supply project that I'm working on, is what I think is a legitimate project. If this thing does kick off, or if it all works, I am actually thinking of releasing it as a kit, in which case I will probably be getting quite a bit of quite a few of these parts. So I'm sure TI would be quite happy for me to get a couple of samples to prove the capabilities and use their parts. Yeah, so I wanted to show you guys that quickly. So that's that. The other thing I wanted to quickly show you is the boards that I've ordered. So this is obviously one of the boards that this is one of the boards I got from I ordered from OSHPark. So you'll see that it fits a standard surface mount tactical press button switch, and over the top of that I'll form this little thing on a lathe or something, just a little piece of acrylic that sits on the top. And you'll see the interesting bit here is the idea is to put an LED in the top of this and have a little pin stick out the bottom. In the version I ordered from OSHPark, you'll see there's 2 little holes over there for those pins to be able to move in and out and be connected. So effectively there'll be 4 pins on each button. I'll be able to connect a plug or solder, depending on how I decide to do it. Probably plug. I like doing things a bit modular so you can replace them. So that's the idea with this. The idea obviously being that this sits flush against your front panel, so that protrudes through however thick you make the front panel, so you have a nice slither of the button coming through, just enough for your finger to get hold of and press. But then this sits flush against the inside of your panel, on the front panel, and this button is then allowed to move the 0.5 or 0.2 millimeter in and out that this thing can do. And you'll manage that depth by the depth of the standoffs that you add on for the screw retaining this entire assembly. So yeah, that's my idea for the buttons on the power supply. The main board, of course, that we've ordered is this guy, our first stage bulk capacitance board, and you'll see, as I'm sure I've shown you guys before. So these are rectifiers just to do the 2 sets of rectification, bridge rectification, our bulk capacitance, and it all fits nicely together. So I'm gonna simply opt for the aluminium cylindrical, the standard aluminium caps instead of the surface mount ones, but this board is printed in a way that will support the surface mount versions as well. So yeah, that's what I've ordered, and we're waiting for that. Can't wait for another set of good boards from OSHPark. The next thing I wanted to show you guys quickly is just the physical, how I test my physical footprints to make sure the board is good before I send it off for manufacture. So here is a basic printout, a 1-to-1 scale printout of the second stage of the power supply board. And what the idea was is to just make sure when you print this thing, I like printing it just on plain paper, and a normal laser printer or something, and just to check the scale of stuff. I wasn't sure, so I created the INA 226's footprint and a couple of other footprints. So I just wanted to make absolutely sure before I order this thing to be manufactured that everything actually fits in it and that kind of thing. So what I normally do is I just print it on a piece of paper. Make sure you get your scaling right. So if you print this, quite often your Windows, for instance, will allow you to scale it to the page or to trim parts off. Just make sure you get all those 1-to-1 scales and trimming functionalities turned off. And then when you print it, you have an exact 1-to-1 scale print of your final board. So this is the second stage as it stands today, and I wanted to check basically the parts that I did get from TI, just that they actually fit correctly onto each of these footprints. So here we have our little INA 226s, and effectively all I'm going to do is I'm going to open one of these guys up. And there you can see that he fits perfectly. So that's a good fit. I'm quite pleased with that. There's a little bit of track or pad space left to do some soldering on, because I do plan to hand solder this entire kit. That's been a big part of the decision for some parts is to make them hand solderable, and this is about the smallest pitch part. I think this is the smallest pitch part that I've got on the design, but yeah, that's still nicely doable. It'll be fun and games, but yeah, we can do that. So okay, let's have a look at the next one. So next up we have our Allen 334, which is our little current what current source? Yeah, adjustable current source. Just to make sure our LT3080s do not exceed or do not go below the minimum current, so that we can push the part all the way down to the 0 volt required. Remember, this power supply was from 0 to 30 volt, whereas most of the other power supplies and things you get cannot actually achieve full 0 voltage, which was a main design feature for me, or design requirement. So that little puppy goes there, and let's see if that works. Yep, another good one. As you can see, once again, pretty good fit. Again, just enough of the pads open to get in there with a decent bit of solder, not too much, and get it all perfectly lined up. Awesome, it's looking good so far. Right, another little part that I did get was the my 3 volt voltage reference. But as I mentioned in the earlier design, I've actually moved that to the board that sits above this. Now I just have an outline print of that. The main reason for these outline prints was to make sure that the holes line up and the boards actually physically sit on top of each other. I didn't print it without the flood fill like I did this one to do the placement checks, but our 3 volt voltage reference will be sitting on our top board, and it'll be sitting around this corner, right out of the way of everything else, not to get it to be impacted by anything else. It'll be right out of the way of our it'll be completely flood filled underneath, etc. So yeah, as I mentioned, this is the first time I design a circuit like this, so it's yet to be seen how all of this works, but that was the idea. So that's it there. I'm not going to unpack him. I'll do another one later on when we review this board. The next part I wanted to quickly show you guys is, basically the last one that I wanted to do today. The LM358. This is our normal little op amps, and there it is. Right, let's have a look at him. So one of them will sit over there. The other one will be put right there. And I think this was a standard footprint, so that one works perfectly. We'll sort that out now. There is a little thing about the LM358 which I didn't notice, but its maximum voltage is I think 34 volts. Now that's obviously the maximum what I'm expecting to get into this board as well, and to that end, I was a little bit worried that that voltage is going to be just a bit too tight. So what I've also done is I've ordered what I'm hoping is a replacement op amp, and that's the OPA 2244. So it's also a dual package. So it's pin compatible with the 358. The exception, of course, being that this one's maximum voltage is actually 36 volts, which should give us at least a little bit of margin rail to rail. And as you can see, that is actually package replaceable, so everything will still fit. And I do need to still go through the full data sheet for this, but for right now it looks like it's going to be a drop-in replacement, which will actually give me the higher voltage tolerance that I was hoping for these parts. I actually do have 5 of these as sample parts from TI. So what I'm planning to do is, because the power supply only requires 2 of these, and I've now got 5 of them, I will be mounting 2 of them onto these little prototype boards from Adafruit. These little guys are actually quite cool. You'll see how they work is there's a what is this, TSOP T-SOP package on this side, SO8 package on this side. It's obviously now this one has all 12 pins, which is obviously not what I'm going to use for this one. But what you do is you would physically just solder it onto the first set of pins. Oops. Obviously these little boards are made to handle any kind of size package, etc. But the longer leads actually does make it a lot easier to solder anyway. So you'll solder it on there, add a couple of pin headers onto the pins that you do need, and it fits into a breadboard, right? So I'm going to be doing doing that to 2 of them, and then breadboarding up the circuits again with these op amps to make sure everything works fine, and we can get on with that. So that was a quick look at the progress of the power supply. Yeah, let me know what you guys think. We're waiting for the boards now. We are about ready to kick this thing really off, start soldering bits together and working on it. If you like this video, as usual, please give it a big thumbs up on YouTube, tell your friends, tell your family. And yeah, just a final note, if anybody's wondering what's up with the fur, I'm supporting the Movember initiative. A couple of friends of ours are getting together and all growing these ridiculous bits of fur, but it's for a good cause. I'll put a link in the show notes for those of you that want to join in and participate. Yeah, it'll be good. It's for a good cause, as I said. Yeah, thanks, and see you next time.